Hi guys, welcome to another episode of MrLopezClasses.com. Today we are going to continue in our book of Corrosion. This is the chapter 9, episode number 2. In this episode we are going to analyze the different type of cathodic protection used in pleasure boats. Until today we know the sacrificial protection system with sacrificial anodes. The material of the anodes depend on the structure of the boat, the hull of the boat, the material, and depend on the type of water. This is the sacrificial anode system that we know until today. We study in details that procedure, the procedure to select the anode, the procedure to protect the hull, the procedure to wire the boat properly and create the bonding system. This is the sacrificial protection system with sacrificial anodes. Now we are going to introduce another system. It's the impressed current cathodic protection. Impressed current cathodic protection. This is, in my opinion, a magic design, a wonderful idea that is used every day more and more and more and more. Today it's used in big boats, in mega yachts, especially in boats with a metallic structure, and is also used in fiberglass boats, basically in a steam drive system. I'm going to explain later at the end of this episode where it's used and how it's used and what is the name of that system. In order to understand the second method, the impressed current cathodic protection system, impressed current, we need to refresh our concept of basic chemistry. You remember at the beginning of this book when we talk about the periodic table, the organization of the elements in the periodic tables, and why some elements are located in one group and in other group. You remember the element located in the group number 8 in the last one? They are called noble gases or noble elements because they have in the last orbit, you remember, 8 electrons. And you remember that the elements in the group number 7 and 6, pretty close to the group number 8, those are the elements with higher energy. They are pretty close to be stable. They need one more or two more electrons to be stable. And we know that the element located in the group number 1 and 2, they normally are donors. They are sacrificial elements. They release the electrons. Yeah? And elements with the 3 electrons also, metals. They have less energy than those elements in the group 6 and 7, fluorine, chlorine. Those elements and oxygen with high level of energy, and they are pretty close to be stable. They only need 1 or 2 electrons to be stable. With that concept, the engineers create the impressed current cathodic protection system. And they say, okay, when an element is stable or a molecule is stable, you remember an example of stable molecules? Water is stable because the molecule is stable, 8 electrons. And water, you remember quickly, water is H2O, you remember, it's 2 hydrogens and 1 oxygen with the 6 electrons in the last orbit, and the hydrogen with the 2 electrons in the last orbit. The hydrogen with less energy release the electron, the oxygen complete 8, and the hydrogens 0 and 0, and the molecule is stable. There are other stable molecules. You remember carbon dioxide is stable. Carbon monoxide no. Carbon monoxide need 2 extra electrons to be stable. Other molecule stable is O2 to oxygen in a covalent relation. In other words, when the element or the molecule is stable, the molecule don't react. For that reason you said, water is stable, no react. That's true. Water is stable, no react. This is a perfect liquid. Yeah. For that reason, you remember the doctor recommend drink 8 glasses of water in order to stabilize your pH. Remember that episode related with the pH? Correct. Those are stable molecules, stable elements. The engineer said, hey, what happens if I try to saturate the structure of my boat? Suppose that I have a boat in aluminum or I have a boat in steel. What happens if I send a lot of electrons? I bombardier the structure with electrons and I saturate the structure. If the structure is stable, fully saturated of electrons in the last orbit, the oxygen not attack the structure and the structure is not oxidized. Bingo! Excellent idea! Excellent idea! It's perfect. I am going to saturate the structure full of electrons, and right now the structure is stable, no react, and the oxygen no attack because it's stable. Good idea. How can I bombardier with electrons the structure? It's too simple. The people locate an electrode close to the structure, not necessarily touching the structure. You can touch with the sacrificial anode the structure, or pretty close, and you introduce current in the anode, not in the structure. In the structure only the negative. And the positive of the anode, because it's pretty close, create a flow of electrons that saturate the structure. This is commonly used in the oil companies, the pipelines of the oil companies. You see, the pipe is protected with the anode. The anode is on the ground, inserted on the ground, is separated from the pipes, and look, the negative is connected to the structure on top, and the anode create the flow of electrons, and the electrons saturate the pipe, and the pipe is protected. The oxygen no corrode the pipe. Wow! Yes, my friends, this is the procedure to protect the pipes, the steel pipes in the oil companies. It's a great idea. It's a perfect idea, and it's also used in mega yachts, in mega containers, the impressed current protection system. Yes, my friend, this is the secret. Oh, and how can I create that flow of electricity? With a small element is basically like this, is a controller. Is an element, a source of a DC current. Is a magic box that produces DC current, and the DC current create a flow of electrons. Magic idea. I love it. I think that this idea will be more sophisticated, more accurate in the next coming years, and will be the method used in the majority of the boats in the future. The impressed current cathodic protection system. Impressed current cathodic protection system. Yes? Okay? It's clear. Until today we have the sacrificial anodes and a new system, impressed current cathodic protection system. We are going to try to understand what is the meaning of that and how the impressed current cathodic protection system works. I explained that the secret is the element that produce the source of DC current, because we are going to send a DC current. Okay, the impressed current cathodic protection system is an external DC current controller, and that element apply a flow of electricity into the pipe, into the structure that you want to protect. This is the idea. You have here the controller, DC controller. You can create a DC controller in different ways. Okay, with a rectifier, you rectify AC current into DC, and you use that DC current. Or with solar panels, you collect the DC power into batteries, and on the battery you connect a controller like the ACR, you remember, and you send AC current into the system. different possibilities. But the solar system is commonly used in the oil companies to protect the pipes to transport the oil from one city to other city. Okay, this is the situation. Look, this is the pipe. This is the pipe that we are going to protect, and those are the anodes. The anodes are inserted on the ground, separated from the pipe, not necessarily touching the ground. The anodes are not sacrificial. Those anodes will be replaced each 15 years, 20 years, because those anodes are not, you don't need that those anodes have a low nobility. Those anodes could be in carbon, or in carbon covered with titanium, or in any type of metals. You need basically good conductors of electricity. Those elements are not sacrificial. Those elements stay over there for a long period of time, and they are not eroded easily like the typical traditional sacrificial anodes. Okay, the range of electrons from the anode to the structure try to saturate the structure metal in order to complete a electron in the last orbit. In this way, the atoms on the metallic structure try to be stable and they don't react with the oxygen. Bingo! This is a wonderful idea. This is a magic idea. And the structure is saturated. You don't need paint the structure. You don't need added coat, nothing, because the structure is saturated and the oxygen no attack the structure. I like that design. In my opinion, this is a magic design. And this is the situation. Impressed current cathodic protection works by delivering controlled amount of DC current. Yeah. Look, this is the DC, the source of DC power. The negative is connected to the structure. The negative is connected directly to the structure. And the positive cable is connected here to the anode. And the anode produces the flow of electricity, the flow of electrons, and bombardier the structure, and the structure is impregnated, saturated with electrons. And right now, it's not possible that the oxygen attack the structure. I like it. This is a good design. The electrical current that is continuously regulated by the controller prevent that the electromechanical reaction and prevent that the oxygen attack the structure. Oh, my friend, I like that system. Believe me, in the future, that will be the system to protect the majority of the boats, the impressed current cathodic protection system. The anodes, the material for the anodes. Palladium is an excellent anode, but normally the anode is not fully in palladium. It's other material covered with palladium. Because the high cost. The typical expectation of impressed current anode is the life of each anode is around 15 years. More than 15 years. You never need to replace those anodes. The anode materials that have proven to be suitable for impressed current system include graphite, silicon, cast iron, or metal oxide covered with palladium. The anodes are produced by electroplating. You remember that method that we analyzed in previous episode? And with that method is covered with a thin layer of palladium. Because the driving voltage is provided by the DC, the source of power, the anode is not necessarily more active. Yeah, you don't need check. It is a good sacrificial anode, because really in this system, this is not a sacrificial anode. It's an anode to allow the flow of current to the structure. This is the function of this. In marine application, is commonly used. In mega container, in mega ships, this method is widely used in static ocean structures. For example, in pipelines, fuel containers, and is also used in cheap cargo containers. Yes, this is very common in those boats. The structure of those boats is in steel. Yes, in those boats they have the controller. The controller is this. They have the anodes, and they have the junction box to connect to do the connection in between the controller and the anodes. The anodes in those boats are called reference anodes. Yes, this is the typical structure. We have anodes here, reference anodes over there, other anode here, and okay, the controller is located here, and there are cells of reference, But it's simple. It's simple. I love it. Those anodes produce a flow of current, here, flow of current, and saturate the structure of the boat, and at the end the structure is fully saturated and the oxygen no attack the hull of the boat. Wonderful design. For internal elements, for example, for the shafts, the current is flowing through those brushes. You remember the brushes uses in the motors, in the alternator, it's exactly the same. The current enter and saturate the shaft with electricity, and the shaft right now is spinning, but with the brushes, the current enter, penetrate, and keeps saturated of electricity the shaft. Nice, huh? This is in my opinion a great idea. Advantage of that systems. You remember that we talked in previous episode how important is keep separated the sacrificial anodes from the structure. You remember that video with the separation? Because if the sacrificial anode touch the structure, produce like an intergranular corrosion in the vicinity in between the sacrificial anode and the structure. This is the inconvenience of the sacrificial anodes. You remember, especially in aluminum boats, what happened in that area, intergranular corrosion. Okay, to eliminate the formation of aggressive corrosion cells on the surface of plates and avoid the problems when you have dissimilar metals, this system avoid that situation. With the impregnated current protection system, you don't have that situation. You don't have that situation around the sacrificial anode in contact with the surface. This is wonderful. This is a great advantage. Other advantage, there are a lot of advantage. You need to replace those anodes, no sacrificial anodes, each 15 years. Reduce weight in comparison with the sacrificial anode, because when you added weight, when you add it, it's a lot of weight. Flux mounted anodes to ensure a smooth hull profile. Yeah, it's not a heavy external metals outside. No maintenance. It's a self-diagnosis. Those systems operate with AC current, and the AC current is converted into DC in the equipment. The control panels are smaller, and it's easy the installation in comparison with the installation of the regular sacrificial anodes method. I love it. Okay, my friends, this is the typical impregnated current protection system. In pleasure boats, is used that system? Yes, it's used, especially in small boats with a steam drive system. In those boats with the steam drive systems, is commonly used the Cathodic system. The Cathodic system is exactly the same. A controller that produces the DC current and send the DC current normally positive and negative in the middle, and two output signals going into the anode, and the anode is touching the outdrive outside. Simple. Simple. This is the connection. Look, this is the connection. It's too simple. The Cathodic electrode system is an impressed current protection system. It's exactly the same. But for a small boat, the Cathodic have the controller, is that one. And the anode is normally located in the bottom of the gimbal in the lower unit outside. Simple. And the Mercathode have 4 terminals. The controller is located in the boat, normally on the block of the engine, and is usually mounted on the engine. The controller sends the signal to the anode, and the anode develops protection on the steam drive unit. Simple. And this is the situation. This is the situation. The controller should be wired directly to the batteries, to the positive and the negative. In other words, this controller have current directly from the batteries. It's not interrupted. Doesn't matter if the boat is off, the controller is suction current, because this element need power to produce power on the anode. Yeah, it's possible to drain the battery with this element if you have excessive potential difference in your boat, because you have a neighbor boat with too much leaks of current, because the salinity of the water, because the alkalinity of the water, because the temperature of the water is high, and the corrosion process is that process is double right now. Those factors affect the corrosion process. Okay. Yes, this is the controller, and the controller keep the anode activated. And in total there are four cables. There are 4 color code wires attaching to the Mercathode controller. One is red for the positive power, one is red, and the other one is black for the negative, and other one orange and brown to connect the anode. Yeah, the middle ones positive and negative for the power, and the externals orange and brown connected directly with the anode in the bottom of the lower unit. Okay, and the orange and the brown wires run down to the anode, and this is the situation. The anode is mounted outside of the boat, and the very bottom of the gimbal housing is a plastic container with 2 bolts. Is this one. It's exactly like this. You are familiarized with the steam drives. This is the anode located in the bottom of the gimbal, and those cables, orange and brown, are coming from the Mercathode. And the Mercathode activate this anode, and this anode send the flow of current and keep protected the steam drive. This is a method that at the beginning was designed. The invention is Volvo, but it's also Mercury. Both of them have the patents for those elements. This is impressed current protection system. I think that system will be standardized and will be updated with a more technique, more sophistication for fiberglass boats with inboard engines. I think that in the future that will be the system to protect against corrosion.